Good morning, AFM students. Today we're going to be in section 8.3 talking about some of these graphs of the trig functions we've been studying. So today is really just about the sine and the cosine graphs. Okay, if you'll look through some of the examples in your book, you can see that these sine and cosine graphs are really just like a wave that just continues to repeat that pattern over and over and over again. The normal period, which is basically one complete rotation or one full cycle, is a length of 2 pi. Just like on the unit circle, after you do a full 360-degree rotation, 360 degrees is the same thing as 2 pi. But what I want you to recall is how in previous sections with previous functions, we have done different types of transformations. We know that when you have a negative number out in the front, that is a reflection over the x-axis. We know that the number inside here with the x controls how it shifts right and left, that the number at the back controls how it shifts up and down. So I want to add just a few extra things that are special about the trig graphs. And again, the great thing about these videos is that you can pause it and take notes. So the number out in the front, if you take the absolute value of the number that is multiplied by the sine, or this could be a cosine function, the absolute value of that is the amplitude. This is basically referring to how high up the graph gets. Now in a unit circle, since the radius is 1, we pretty much just get up to 1 or down to -1, and that would be your amplitude is the length of 1. But if I were to stretch this vertically, let's say it gets up to 2 or gets down to -2, then your amplitude would be something other than 1. So whenever you look at an equation, the absolute value of that number multiplied out front is going to be the amplitude, which is kind of like the height of your graph. Now the period is how long it takes to make one full revolution. The way that you find the period is take 2 pi and divide by that constant k. The number k, or that constant there, is going to be the number that's factored out in the front of whatever you're taking the sine or the cosine of. Okay, B is the phase shift. Now, we've never called this phase shift before until we got to the trig. Basically, it's how it would slide to the right or to the left. And then the number C at the back is going to be the vertical shift up and down. That has not changed any at all. So your homework tonight, you're just going to have to tell me about amplitude, period, and phase shift and describe any other transformations that you see. So we're going to start with example number 1 from the book. And in this example, we're just going to describe the transformations. For example 1a, they give us the function f of x is equal to 2 plus the cosine of x. Now I'm going to rewrite this as the cosine of x with that plus 2 at the back. The only transformation we see here is this plus 2 at the back is going to make the graph shift up 2. Notice that the number out in front would be an understood 1, so the amplitude would be 1. And the constant in front of your variable x here is also just an understood 1. So if I wanted you to find the period, we would have 2 pi divided by 1, which is still 2 pi. That's the normal rotation. So really nothing's changed except there's a plus 2 at the back, which means the whole thing will shift up 2. Now in example 1b, we have the function g of x is equal to the opposite of cosine of x. The only thing that's going to change here is that negative out in front is a reflection over the x-axis. The absolute value of -1 would still be 1, so your amplitude would still be 1. The constant in front of your variable x is still an understood 1, so the period would just be 2 pi divided by 1, so the period would still be 2 pi. The only transformation that's occurring here is just going to be a reflection over the x-axis. Okay, let's try another example. If we look at example number 2, they give us the equation y equals a -3 times the cosine of x. So when I find my amplitude, I'm going to take the absolute value of that -3, so the amplitude is 3. If I come back to this graph over here, that means instead of your graph just getting up to 1 and down to -1, that it would grow up to 3 and come down to -3. It's just making this wave much, much taller. So to find your amplitude, you take the absolute value of that a. In this example, it's 3. Now the period again is 2 pi divided by k. K is the coefficient of your variable here, so since it's just an understood 1, 2 pi divided by 1 is still 2 pi. But don't forget, whenever there's a negative out in front, that represents a reflection over the x-axis. So in example number 2, this is what you would have to tell me. There's a reflection over the x-axis. The amplitude is the absolute value of that, which would be 3. And the phase shift is just 2 pi over 1, which is still just 2 pi. Okay, 2 more examples before you get started. Example number 3, I just rewrote the formula so that you could remember the number out in front is how you find your amplitude. The constant k, that's the number or the variable, the number in front of the variable. Now in this example, there is nothing being added or subtracted inside with the x. And there's nothing that's being added at the back. So in this example, there is no phase shift. There is no shift right and left. There is no vertical shift up and down. So here I just basically have that my A is 4 and my K is 3. That means the amplitude is the absolute value of 4, which is 4. And the period, how long it takes to make one full rotation, is just 2 pi divided by K. So in this example, since the K is 3, your period is 2 pi thirds. Again, there's no phase shift and there's no vertical shift. Okay, one last example is going to be example number 5. Now in this example, we have y equals 3/4 times the cosine of the quantity 2x plus 2/3 pi. So what I'm going to do is, since our k has been distributed inside the parentheses, I'm going to do the reverse of the distributive property and take this out kind of like a GCF. So if I factor out 2 like a GCF, 2x divided by that 2 will just be x, and 2/3 pi divide out that 2 is just going to leave a 1/3 pi. So now when I look at this formula here, I can see that my A is the 3/4, my K value is 2, and then there is an X plus pi thirds on the inside. So let's break this down. The amplitude will be the absolute value of that 3/4, which is 3/4. My period is 2 pi divided by the K. So 2 pi divided by 2, the 2 on top and 2 on bottom will cancel, so that's just pi. Remember, when there is a plus in here, it really is going to shift to the left, pi thirds, and there's nothing at the back, so in this example, there is no vertical shift. So for your assignment for today, I want you to do the problems that I've listed on Google Classroom. Make sure you're just doing every other even, and just tell me about the period and the phase shift and the amplitude and any other transformations that you may see. Let me know if you have any questions. Good luck.